Hello guys. Okay, so today we are going to be looking at problem 1.1 of the Strengths of Material textbooks. So the problem states two solid cylindrical rods AB and BC are welded together at B and are loaded as shown. Knowing that diameter 1 equals 30 millimeters and diameter 2 equals 50 millimeters, find the average normal stress at the midsection of A, rod AB, and B, rod BC. Alright, so let's start working on A first. Oops, it's a little bit thick. Okay, so first thing we should do is convert the diameter 1 from millimeters into meters. So diameter 1, 30 millimeters is 0.03 meters. Alright, now recall that the formula for normal stress is equal to the force P divided by the area which it acts on. So first things first, let's find the area of section AB. Okay. Oops. So the diameter is 0.03 meters. The area of a circle is pi 4, then the diameter squared. So that's going to be pi over 4 times 0.03 squared. I have that crunched out already somewhere. The area is going to be 706.86 times 10 to the negative 6 meters squared. Now let's find the force that is acting on the midsection of the rod. So to do that, we're going to take a cut right in the middle over there. So let's do that. So here's A. We take a cut. And then when you take a cut, you have a force pulling this way. We'll just call that FAB. And we also have this 60 kilonewtons going over here. Right? So let's sum the forces in the X to find AB. So sum of the forces in the X equals negative 60 plus FAB equals 0. And then solving for the force, you get FAB equals 60 kilonewtons. Alright, so now we have everything we need to plug into this equation right over here. So let's go ahead and do that. So sigma AB is equal to 60 and then times 10 to the third, because it's kilonewtons and we want it to be in newtons, divided by 706.86 times 10 to the negative 6 meters squared. And now we have 84.88 times 10 to the 6 pascals. Let's go ahead and convert that, make it more simpler. That's also the same as saying 84.9 megapascals. Right? So that's the answer to part A. Okay, now let's do part B. So first, let's convert D2 into meters. So 50 millimeters is 0.05 meters. Now let's do the area is equal to pi over 4 times 0.05 squared. and that should crunch out to about 1.96 times 10 to the negative third meters squared. All right, now let's find the force. So now we're going to cut over here, right? So we have, this is A. Now we have B. We have a cut over here. Now we got a force BC going over here. We still have our 60 kilonewtons. Now we have a 125 over here and a 125 over here. All right, now same as before, we're going to sum the forces in the X. So we get sum of the forces in the X equals force BC plus 125 plus another 125 minus 60 equals 0. And then when you calculate that, you should get force BC is equal to a negative 190 kilonewtons. So now we can use our stress equation. So sigma BC is equal to negative 190 times 10 to the third newtons all over 1.96 times 10 to the negative third meters squared. And that should get you negative negative 96.76 times 10 to the 6 pascals. Oops. Times 10 to the 6 pascals, which is also the same as saying negative 96.8 megapascals. And there you have it.